range it's operating in?
Exactly. Is where x is. Excellent. So, like with the squeeze theorem, we had to build the function, right? We had the squeeze theorem, and we started with sine x is between -1 and 1, and we multiplied, we divided, whatever, to get the function in between. And that's the same idea here. But we're starting with x because that's what I know about x. It's definitely between -1 and 1. What am I trying to build is this. This is my target. I want in here, I don't care about these sides, but I want in here to have that. And then the last step would be to integrate. Piece of cake. Okay, so let's continue. If x is between -1 and 1, can anyone tell us where will x squared be? Think for a moment and tell me. I'll get a sip of water in the meantime. What do you think about x squared?
It'll always be less than 1.
And what type of number? Say it again.
Positive.
Very good. That's exactly it. Look at the function x squared. If x is between -1 and 1, where are the function values? Between 0 and 1. So this is for x squared. So if x is between -1 and 1, x squared will be between 0 and 1. Great job. What do I build? What do I need to do next in order to build my function? What should I do next? Anyone? Ten, what do you think? Ten, are you with us? You're just...
I'm just thinking about the problem.
Okay. I thought you were just giving us problems and you walk away.
No, I'm thinking about what to do there. So, would we multiply both sides by... No, that wouldn't work actually. No.
Anyone, what do you think?
Do you do the x squared plus 1?
Very good. So we have to add 1 to all three sides. 1 less than or equal to 1 plus x squared less than or equal to 2. We are closer now. What will be the next step?
To put the square root around everything?
Yes, very good. The question is, so we are applying the square root to all three sides. And I've always said, be careful with the square root, because I have to make sure that all these are positive numbers, right? Are they all positive numbers and in ascending order, right? So therefore, I can apply the square root to all three sides. Excellent, thank you. Was it Jordan?
Yes.
Thank you.
What if they weren't all positive numbers?
Then I cannot apply the square root, then I'm in big trouble.
Okay.
Yeah, because I cannot apply the square root to a negative number. Good, so we accomplished what we wanted. We found the function squeezed between, so to speak, between two constants. And this is definitely smaller than that. Everything is in ascending order. I can apply the integral to all three sides. So this is the integral from, don't forget dx, don't forget dx, don't forget dx, and don't forget -1 to 1. So the middle part is not touchable. I just have to copy it. So now, what is the antiderivative of 1?
1x.
Very good. Excellent. From -1 to 1. What is the antiderivative of 1? Good. So now I plug in 1 and I subtract when I plug in -1. What do I get on this side? Let me write it. 1 plus 1. And this is what the problem was asking us to do. So the left-hand side is 2. The integral -1 to 1, the square root of 1 plus x squared dx. less than or equal to the square root of 2. So, without even knowing how to evaluate this, we are not equipped at this point. We were able to show that it's definitely a number between 2 and 2 the square root of 2. Good? This was 67. Now let's look at 68. Any questions on 67, please? Anything? Any questions here? Anyone? Any questions? Okay, let's take a look then. Let me share my screen again. And we said 68, so I'm copying it. So pi divided by 12 is integral from pi over 6 to pi over 3 from sine x dx less than or equal to the square root of 3 pi over 12. Okay. This we can determine with no problem. We can determine the antiderivative of sine x, which is negative cosine x, and we can plug in this and we determine this exactly. But this is not what the problem is asking us. They're asking us to show that this integral is a number between pi over 12 and the square root of 3 pi over 12. So where's my starting point? Anyone, please. Anyone I haven't heard from today? Derek, Trey, Mickey, anyone? Carson, anyone? Oscar?
Is it like the range pi over 6 to pi over 3?
Excellent, thank you. That's our starting point. And now we have to determine, of course we have to apply sine, but I have to be very careful. Because I have to check whether sine is an increasing function on this, sorry, it makes no sense, pi over 6 to pi over. So I have to make sure that between pi over 6, which is 30 degrees, and 60 degrees, the function is increasing. Because if I have cosine x, the function will not be increasing. Okay? So let's take a look at, this is the graph of sine, so this is pi over 6, and this is pi over 3, and the function is increasing. So when I apply sine to all three sides, the symbols do not change. So sine pi over 6 is definitely less than or equal to sine x less than or equal to sine pi over 3. However, this is not the situation, but I want to caution you. Look at cosine. So this is pi over 6, and this is pi over 3. Look what happens here. I can write that cosine is between pi over 6, that x is between pi over 6 and pi over 3. But when I write this, the inequality symbols will be changed. Cosine pi over 6 is bigger than cosine pi over 3. Be very careful with this inequality, or any inequality. You have to check whether the function is increasing or decreasing. You keep the inequality symbols or you don't. Okay, sine pi over 6, anyone?
One-half.
Very good, thank you very much. And then the other number, the square root of 3 over 2. So 80% of the problem is finished. We were able to show this already, so now we are applying the integral. And it's done. So this is the integral. Don't forget the x. And this is between pi over 6 and pi over 3. Pi over 6, pi over 3, pi over 6, and pi over 3. We apply the definite integrals property. Okay, the next, this is 1/2 x. You already told me that. Pi over 6 to pi over 3. The middle doesn't change. And this is the square root of 3 over 2x from pi over 6 to pi over 3. So pi over 3 minus pi over 6. Pi over 6, pi over 3, sine x dx, and the square root of 3 over 2, pi over 3 minus pi over 6. it turns out that, where is my problem? Right here. It turns out that this, right, pi over 3 minus pi over 6 is pi over 6. This is 60 minus 30, right? So this is pi over 6. That's why we have here pi over 12. And this is again pi over 6. That's why we have here the square root of 3 pi over 12. So the inequality was proved. Any questions? Any questions? I would like to move on then. Now, I'd like to talk about Fundamental Theorem of Calculus Part 1. So I think this is page 5, yes. So this is in 5.3, FTC Part 1. And we'll go back and just refresh our memory on FTC Part 2 as well. Okay? So finally, in other books, you'll find this was Part 2 and this is Part 1. It doesn't matter. It's not important. So what is this all about, Part 1? We know what Part 2 does. It shows us, it teaches us how to find the integral from a to b from f of x dx as f of x, the antiderivative of f of x from a to b, eventually f of b minus f of a. Of course, for a continuous function, this is what Part 2 is teaching us, how to determine definite integrals. Okay, what is Part 1 all about? Okay. FTC Part 1. Part 1 is telling us or showing up to us that, proving to us that differentiation and integration are inverse operations. Differentiation and integration are inverse operations. In other words, what does that mean? When I integrate f of x dx and I differentiate it, I get the function. This operation and this operation cancel out. Why? Integration and differentiation are inverse operations. It's like, for example, taking the square root of x squared. The square root and squared are inverse operations. It's like applying a natural log to e to the x. I just get x. Here it's a little bit iffy. I get the absolute value a little bit different. But when I apply natural log to an exponential, or a log to an exponential, same base, they have to be the same base, then I get a function. Then I get just x, right? Or the function of x up here, it doesn't matter. So this operation cancels this operation. This operation cancels this or vice versa. This one cancels this. This one cancels this or vice versa. Also, when I have a derivative and I want to integrate it, I get the function. Why? Because when I integrate a derivative, these two operations cancel one another and I get the function. When I differentiate an integral, I get the function. When I integrate a derivative, I get the function. Because differentiation and integration are inverse operations. Okay. How? What? Show me. Okay, so I'm trying to show you. Let's take a look at how this works. This is a function, f of x. And this is an interval, a comma b. This is the area under the graph. And can anyone give us the formula for the area? How do I write the area? Anyone? Anyone? Derek? Oscar? Carson? Anyone? Yes.
The integral
Yes.
a to b
Yes.
of f of x dx.
Awesome. Great job. This is it. That's what this means. Good. Okay. Now, I'm going to change the notation a little bit. I'm going to say that this is t. So this is a function now, f of t. Who cares? F of t, f of x. But you'll see why I changed that. And this is the same thing, a and b. And this is the same area in question. This time I'm going to pick an x. I'll say x is a number anywhere between a and b. And I'm going to ask you, how do I write this area now? This. Can anyone help us to write that area?